Hello everyone, hope you are doing well. I am Akshay Parmar, Assistant Professor at LJ Institute of Engineering and Technology. Welcome to the video tutorial series of data communication and the computer networks. Today we will discuss multiple access link and its one type channel partitioning protocol. Let's discuss about today's outline for this video. First of all, we will discuss what is multiple access link and its type. After that, we will see its one type and its subtype, TDMA, FDMA and CDMA. All of you are enjoying the Wi-Fi, right? So you have one question arrived. How this Wi-Fi technology is working and how they are dividing its spectrum to use all of them. In today's era, everyone is enjoying the Wi-Fi, right? So you have one question arrived. How this Wi-Fi technology is allowing to access multiple user with the single router, right? The similar kind of way. And single mobile tower a single mobile tower is serving so many users in its spectrum, right? So how they are working? So for that, let us discuss about what is multiplexing first of all. So in that there are so many several sources are used are multiplexed and combined in the multiplexer. The multiple resources are combined together to share on the common channel. After that, at the receiver end, at the demultiplexer, that shared common channel, they get that channel, and after that they are dividing that so many sources in that, right? So the multiple access link is the one of the application of the multiplication, right? So there are mainly two types of the network link, right? Peer to peer. First of all, point to point link. A point to point link consists of a single sender at the one end of the link and a single receiver at the another end of the link, right? So this is the point to point link. After that, the another type of the network where the broadcast link is there, right? So what do you mean by the broadcast list? A broadcast link can have multiple sending and receiving nodes, and all nodes are connected to the same single and shared broadcast channel, right? As you can observe that in the telephone network, in the cellular network, and in the Wi-Fi network, like that, right? So they are the broadcast link. Where point to point link is whenever you are sending mobile to mobile transfer, right? So just like an Bluetooth technology, right? So this is the point to point link and the broadcast link that we have seen, right? So the term broadcast is used here because when any one node transmit a frame, the channel broadcasts the frame to on each of the nodes receiving a copy, right? So whenever you are sending a data in the broadcast link, every receiver is receiving that nodes, right? And after with the destination address, the one who needs that information, the one who is sending that information can only access that data, right? So that's how the broadcast link is working. After that, let's see its type, right? So category of the multiple access, there are mainly three categories of the multiple access protocol. First of all, the channel partitioning protocol, right? So in the channel partitioning protocol, there are several in that it divides a channel into the smaller pieces such as the time slots, frequency slots. In this channel partitioning protocol, we divide the channel into the smaller pieces. That pieces can be in the terms of time slot, in the terms of the frequency slot, or in the term of load, or in the term of code slot, right? So that's how the channel partitioning protocol is working. It allocated a piece to the node for the exclusive use, right? So whenever the one piece of the time slot or the frequency slot or the code slot is there, they are assigning to the one sender and one receiver, right? So that allocate that piece to node for exclusive uses, right? So example of the channel partitioning protocol are TDMA, the time division multiple access, right? So in that the channel is divided into the time slots, right? After that, the another type is FDMA, the frequency division multiple access. In that the channel is divided into the smaller pieces of the frequency ranges, right? So in that the frequency range is assigning to the channel, right? And after that, the last one is the CDMA, the code division multiple access. So this is about the channel partitioning protocol. After that, the another type is that. So what is that? That is the random access protocol. In that, the channel is not divided and allow the collision, right? So in that, the channel is not divided and allow collision. After that, they are recovering from the collision, right? So example of the random access protocol is MEC, the medium access control protocol, right? So pure aloha, slotted aloha, CSMA, CSMA CD and CSMA CD are the example of the random access protocol, right? And the third type of the multiple access link is taking turns protocol, right? So nodes takes turns, but nodes take turn, but nodes with more to send can take longer turns, right? So this is about the taking turn protocol. Example of the taking turn protocols is the polling and token passing, right? So this is about the categories of the multiple access link, right? So first of all, we will see the TDMA, the time division multiple access. So what do you mean by the time division multiplexing, right? So first of all, suppose the channel supports n nodes and that transmission rate of the channel is Rbps, bit per second. So in the time division multiple access, it divides time into the time frames and further divides each time frame into the n time slots, right? So that's how the TDMA is working. Each time slot is then assigned to the one of the n node, right? So let us discuss about how it's working. So in that, the time is divided into the 6 slot, and in this example, the time slot 1, 3 and 4 are assigned for the transmission, that they are divided into the n time slot, right? So that this time is divided into the time frame, right? So here we have the time frame, and that time frame is divided into the time slot. In that, in our example, we have taken a time frame, and this frame is divided into the 6 time slots. After dividing that time slots, each time slot is then assigned to the one of the nodes, right? So in this the time slot 1, 3 and 4 are assigned to the one of that nodes for the accessing, right? So example, the 6 station lane 1, 3 and 4 have packets, and slots 2, 5 and 6 are ideal because it is not assigned to any of the nodes, right? So there are the wastage of that time slot, right? So major drawbacks. First, a node is limited to the average rate of R by n bits per second, even when it is the only node with the packet to send, right? So right after that, the second drawback is that the node must always wait for its turn in the transmission sequence again, even when it is the only node with the frame to send, right? So in that, so let's take an example. If we have the only one node to send the data, right? The node 1 is sending the data. After that, all that 2, 3, 4, 5 and 6 are ideal slot, although the time slot that node has to wait for that its turn whenever it is taking in the next frame and its turn is there, right? So it have to wait. So there is the wastage of the time slot. This is the major drawback of the TDMA, the time division multiple access. Let's say by example. In our example, this is the frame, right? This frame is divided into the several chunks, right? So the time slot 1, time slot 2, time slot 3 and so on. So that frame is divided into the t second. So this is the frequency spectrum, right? And this frequency spectrum is divided into the time slot in the TDMA. After that, each time slot is allocated to the node, right? This is the node 1, this is the node 2, this is the node 3, this is the node 4, right? After that, that time slot is allocated to the one dedicated nodes, right? Between the two time slot, we have the transmission interval. By that, we are avoiding the collision of that two frequencies, right? Or two time slot, right? if we are not having that time in transmission interval, then it might be that time, so that its data is collide, right? They are interfacing, right? So like that, the time division multiple access is working. In that, the users or nodes are having its particular time slot for the transmission, right? After that, they have to wait for the next turn. In the next frame, they are having its time slot, right? So that's how the time division multiple access is working, right? That's how the TDMA is working in real life. After that, the frequency of the 2 kilohertz, right? So the TDMA is working in the second generation in the GSM, GPRS and Edge, right? So in that, that slot is divided, right? So we are in that, we are dividing that time slot we are dividing that frame into the 9 time slots, right? 0, 1, 2, 3, 4, 5, 6 and 7, right? So so time slot 0 is work as a transmission interval, and after that the 0, 1, 2, 3, 4 are working there, right? So that time slots are assigning to the dedicated node, right? So after that, whenever the next frame is there, the nodes are having the same number of the time slot, right? So the channel is could support only the 8 active user at a time. The TDMA is the application. The second generation of the GSM, GPRS and Edge are using the TDMA technology, right? The time division multiple access. After that, let's move forward about the FDMA, the frequency division multiple access. So what do you mean by the FDMA and where it is used, right? So and how it is working. So in that, in our TDMA, we are dividing the time into the smaller number of the interval, right? So we are dividing that time frame into the time slot. In that, in the FDMA, in the frequency division multiple access, the channel spectrum is divided into the frequency band, right? So each station is assigned a fixed frequency band, right? After that, unused transmission time in the frequency band goes idle, right? As we are as we have seen in the TDMA, that unused time slot are that unused time slots are goes idle. Like that, unused transmission time in the frequency band goes idle, right? For an example, 6 station lane 1, 3 or 4 have the packets and frequency band 2, 5 and 6 are idle, right? So this is the FDM cables, right? After that, we are sending the data through that, right? So in that, there are the so many frequency ranges in that. So this is the higher frequency, middle frequency and lower frequency, like that. So that frequency is divided into the so number of frequency bands, right? So we have the 6 station line. So we have the frequency 1, frequency 2, frequency 3, frequency 4, frequency 5 and frequency 6, right? So whenever we want to send the data using the FDMA, that one dedicated frequency range is assigned to the node. Why that node can transmit its data in that frequency range only, right? So there are the 6 frequency bands. In our example, that node 1, 3 and 4 is having the packets to send. So they are occupying that frequency range. It is assigned to them. After that, the frequency band 2, 5 and 6 are not having any data to send. So they goes idle in that, right? So that's how the frequency division multiple access is working, right? So in real life example, let's say an example, this is the frequency range, right? So we are dividing that frequency range into the smaller number of parts. This is the frequency 1, this is the frequency 2, this is the frequency 3 and this is the frequency 4, right? So frequency spectrum is divided into the number of the frequency ranges, right? And after that nodes are assigned that dedicated frequency range for the transmission. For an example, that user 1 is having the frequency range of 1, user 2 is having the frequency range 2, user 3 is having the frequency range 3, and user 4 is using the frequency range 4, right? So all the users have the different kind of frequency ranges. and between them there are the frequency interval also. So by that we are avoiding the collision of the data, right? So that's how the frequency division multiple access is working. In the FDMA, the frequency is dividing in the smaller number of the ranges, right? So that frequency slots. In the TDMA, that time is divided into the smaller number, that time frame is divided into the time slot. And in the FDMA, that frequency spectrum is divided into the frequency slot. And that frequency slot is allocated to the different number of the users or different number of the nodes, right? So that's how the FDMA is working. After that, let's see the CDMA, the code division multiple access. So what do you mean by the code division multiple access? The CDMA assigns a different code to the each node, while TDMA and FDMA assigns time slot and the frequency slots respectively, right? So as we have seen how the TDMA is assigning the time slot to the nodes and how the FDMA is assigning the frequencies to the that nodes, right? So each node then use is its unique code to encode the data bits it is sent, right? So after that, if the code are chosen carefully, CDMA networks have the wonderful property that different nodes can transmit simultaneously, right? So in our example, we have seen in the TDMA, the nodes have to wait for the several time, right? The ideal time for they are waiting there, right? But in the code division multiple access, if the codes are chosen carefully, the CDMA networks can have the wonderful property that different nodes can transmit the data simultaneously. The respective receiver correctly receive the sender's encoded data bits in the spite of interfacing transmission by other nodes, right? For an example, the CDMA is used in the military and widespread civilian use, right? Particularly in the cellular telephony, right? So because CDMA is used so tight to the wireless channel, right? So that's all about today's session. Thank you for the watching.